Today, I want to talk about solving basic exponential equations. So let's get into it. So let's say we have something in the form a to the power x equals b, and we want to solve for x. How do we do that? Well, what we're going to do is we're going to take the log base a of each side. So we're going to get log base a of a to the x equals log base a of b. Now, if you know your log properties, you'll know we can take the x out because of the power rule. So we get x times log base a of a equals log base a of b. Now, log base a of a is just 1. So that goes away, and we get x equals log base a of b. And that's the general form for it, right? If we want to go from this to this, that's what we're going to do. So let's erase that and let's do a practice problem. Let's say we have 2 to the power x equals 8. Okay? Now, what are we trying to figure out? We're trying to figure out if we raise 2 to some power and that equals 8, what is that some power? Right? So we're going to start off, right, by just taking log base 2 of each side. So log base 2 of 2 to the power x equals log base 2 of 8. Okay? Then, once again, we can take out the x and we get x times log base 2 of 2 equals log base 2 of 8. And then this will cancel out and we get x equals log base 2 of 8, right? And now, all we have to do is, so you could take your calculator and you could put it in, right? But eventually, at some point, you'll just gain an understanding of what this is asking you, right? And you'll see that this equals 3, so x equals 3. And we can test that out. Let's put that back into here, right? We get 2 to the power 3. That does, in fact, equal 8, so we are correct there. Now, let's say we have something like, I don't know, let's do 3 times 3 to the power x equals 27, right? How do we figure this out, right? Well, what we're going to do is we're going to start off just by dividing each side by 3. So we divide each side by 3, divide by 3, divide by 3. This goes away, and we're left with 3 to the power x equals 27 divided by 3. That's 9, right? Then, from here, once again, we're going to take log base 3 of each side. And it's the same exact thing. I'm going to move a little quicker this time. Log base 3 to the x equals log base 3 of 9. Now we can take the x out and that'll cancel out, and we get x just equals log base 3 of 9, right? And this just so happens to equal 3, right? Now let's try something else. Let's try e to the x equals 5, right? And what is this power? Well, when we have e to the x equals 5, what we can do is we want to take log base e of each side. Log base e is just natural log. So we're going to take the natural log, denoted ln, of e to the x, which equals the natural log of 5, right? Then, once again, we can take out the x and we get natural log of e, right, equals the natural log of 5. Natural log of e, that's log base e of e, right? And just like in the past few problems, we saw if we have log base a of a number a, that just equals 1, right? So this will cancel out, and we get x equals the natural log of 5, right? And you could approximate that, right? But we're not going to approximate it, right? This is not a good solution. Well, it's not good looking solution, so we're going to leave it as just natural log of 5, right? That's the best looking solution we have. Now, let's step it up a little. Let's do 3 to the x plus 5 equals 32, okay? So we start by subtracting 5, minus 5, minus 5, and we get 3 to the power x equals 32 minus 5, that's 27, right? Then we have that, and once again, we can take log base 3 of each side. So we'll get x equals log base 3 of 27. okay? And that will just equal 3, okay? So now what we want to do is I'm going to give a more challenging problem, okay? And I think y'all are ready for this. So let's do e to the x, right, plus 2, let's do minus 2 e to the negative x plus 1 equals 0. Okay? Now, this one's a little bit more confusing, right? Because now, or we have an e to the x and an e to the negative x, right? We're going to have a tougher time isolating x. But what we can do, and what a good solution here is let's try to get rid of this negative x. And how can we do that? Well, we can, hopefully you know your exponent rules by now. We can multiply every single part by e to the x. So e to the x times e to the x is e to the 2x, right? Then this will just become minus 2. 1 times e to the x is e to the x, and that will equal 0. Let's rearrange this a little. We get e to the 2x, right, plus e to the x, right, minus 2 equals 0. Okay? Then from there, once again, it still looks a little fishy, but you've seen problems like these before. This is just a quadratic, okay? Let's say y equals e to the x. Let's take a little break and say y equals e to the x, okay? And now let's put that in. All right, so now we have y squared plus y minus 2 equals 0. And now let's solve for y. Well, we can start by factoring this, right? We can change this to, well, what can we change it to? What multiplies to negative 2 and adds to 1? We'll have y plus 2 and y minus 1 equals 0, right? So now we get y plus 2 equals 0 and y minus 1 equals 0, okay? Then from there, we get y equals negative 2 and y equals 1. Then from here, what do we want to do? Well, we know y equals e to the x. So let's just substitute in e to the x. So we'll get e to the x equals negative 2 and e to the x equals 1. Now, from here, let's take a look at our two solutions. Can e to the x ever equal negative 2? Well, if we look at the graph of e to the x, we'll see no, it can never equal negative 2. So this is not a viable solution. Right, now let's look over to this one. Let's take the natural log of each side. So we'll take the natural log of this, and so x will equal the natural log of 1. Now, something I forgot to mention, log, hopefully you know this by now, a log base, and whatever the base is, of 1 will always equal 0. Okay? Now this equals 0. So our solution is x equals 0. Let me know if I said anything wrong or if you have anything additional to add. Hopefully you found that helpful in learning how to solve basic exponential equations. Have a great day.